Welcome back. In this video, we are going to start talking about solving equations, linear equations with one variable, and then in the second half of this lecture, linear equations with two variables. Firstly, just to remind ourselves, what do I mean by an equation? An equation is any sort of a mathematical statement that has an equal sign in it. If you don't have an equal sign, that would be something that's not an equation. So something like 3x plus 2, that's not an equation. There's no equal sign there. But if I were to say 3x plus 2 equals 7, now that is an equation. And when we have equations, what we're interested in is finding the solutions, finding the values that satisfy the equation. Remember, when I say satisfy an equation, I mean that it makes it a true statement. So a value that we put in that would make the left side equal to the right side, that would be a value that satisfies the equation. And if we take all the different solutions, all the values that satisfy our equation, then that would be our solution set, our collection of all the solutions. Things that we can do to solve equations. This is, again, hopefully very old news. You can swap what's on the left side with what's on the right side. You can add the same amounts to both sides or subtract the same amounts from both sides of the equation. You could simplify things. You could simplify one side of the equation and replace it with something equivalent. One thing that I wanted to point out here are two important ones, the last two bullet points. Number one is that we could multiply or divide both sides by the same non-zero expression. So we are going to have to be careful here. And when I say non-zero expression, I'm talking about something involving variables that does not take on the value of 0. If it does take on the value of 0, we're going to have to account for that, and we'll talk about that when we see some examples going forward. But we'll need to keep in mind, whenever we're multiplying or dividing both sides, are we multiplying or dividing by something that could be equal to 0? If so, we'll need to think about that. If we're just multiplying or dividing by a constant, that's not a problem, because if that's not 0, then you know. The other technique that we have, and this sort of sets up the idea of solving by factoring, if you know that two things multiply together to give you 0, then you know that the first thing is 0 or the second thing is 0 or both. And we'll apply that later on when we're solving equations by factoring. Remember, by factoring, we would write something as a product of factors multiplied together. And if we had a bunch of factors multiplied together equal to 0, then the individual factors themselves could be equal to 0. So for example, here I have this equation has the solutions are 1 and 2. The reason I know that the solutions are 1 and 2 is since x minus 1 times x minus 2 is equal to 0, then x minus 1 is 0 or x minus 2 is 0. And that means then that either x is 1 or x is 2. That those would be the values that satisfy that equation. The solution set, I write it with set notation. Set notation involves curly brackets. Those curly brackets are always used to represent a collection of things. So I would read that as the set containing 1 and 2, or the collection is 1 and 2. Those are the two numbers which are the solutions to that equation. The other thing that you can also note here is you can check to see if you were correct by substituting in the value for x and seeing does it make the left side equal to the right side. If you put in 1 for x into this equation, will it make the left side 0 and the right side also 0? And it does. So that's how you could confirm that yes, x equals 1 is a solution. And similarly, if you were to substitute x being 2, if you put in 2 for x, you would find that the left side and the right side are also equal to each other. So that's a way that we can confirm our solutions. And that's an important thing. For a lot of the work that we'll be doing, there'll be some cases where it will be mandatory for us to check our solutions because there may be some extra things going on that we're going to get into in future sections. But even if you're looking at a simple problem like this, x minus 1 times x minus 2 equals 0, if you have a spare moment, it doesn't hurt to check your solutions, because once you've checked them, you can now be confident that, yes, my answers are correct, and then I can move on. Now, there are different kinds of equations, and I'm not going to really labor over this too much, but if we're thinking about equations, there are three possibilities. The one that we're usually seeing are the middle ones, the conditional equations. Those are equations that have some values of the variable that make the left side and right side equal, but others do not. So, for example, something like this, 3x minus 1 equals 0, that's a conditional equation because there's only one value for x that makes the left side and the right side equal to each other, and there's other values of x that do not. But there's two other options. You could have equations that are always true statements. Those are called identity equations. So, for example, this equation, 2x minus 2 equals 2 times x minus 1. No matter what value for x you put in, the left side and the right side will always be equal to each other. So this will be true for any real value of x. So for this, you would say that the solution set is all real numbers. The symbol that we use for the set of all real numbers looks sort of like a fancy letter R. So sort of a double stroke vertical line and then a capital letter R. That's the symbol that we use for the set of all real numbers. So you'll sometimes see me writing that symbol, and when I write that symbol, that is representing the set of all real numbers. If we wanted to write out that x has to be a real number, what I could write is this. I could say for my solution set, I could say the solution set is the set of all values of x where x is an element of the real numbers. This is set notation again. The curly brackets are telling me that I have a collection. This is the collection of all x values. The vertical line that I've drawn there, I could read that as meaning such that, or with the property that. So this is the collection of all x's such that x is an element of, or is a member of, and then capital R, that's the set of real numbers. Of course, if you just write in words, the solution set is all real numbers, that's also fine with me as well. I think it's good to see this notation because it does come up in other courses, so for future math work that you'll be doing, you may see this notation again, so good to get used to seeing it now. The other kind of equation that we could talk about is an inconsistent equation, and that's one where there's no solution. So something like this equation, x minus 1 equals x minus 2, that has no solutions. There's no value of x that you can put in that will make the left side equal to the right side of that equation. And the reason we know that is if you were to take this equation and simplify it, move x's to one side and move constants to the other, so if I moved the x to the left side and move that -1 to the right side, then this would give me the equation 0 equals -1. And that's certainly not true. That's completely a false statement. 0 is certainly not equal to -1, and that's how I know that that's an equation that is inconsistent. It's an equation that has no solutions. So if you wanted to describe the solution set using set notation, you could say the solution set, you could write in words no solution, but you could also say in symbols, using the same curly brackets that we did before, curly brackets with nothing inside of it. So because there are no solutions, our solution set has nothing inside of it. That's another way that you could write no solutions. Again, not super important to be hung up on that particular little bit of notational detail, but again, it is something that you might see going forward. Another way to write a set that has nothing in it is a 0 with a slash through it. That's not the number 0, that's representing, again, the empty set, a set that's got nothing inside of it. So in other words, that would be another way of describing no solutions, that there's nothing inside that set. Now, let's get to solving some linear equations. When I talk about linear equations, linear is referring to the degree of the equation being 1. So any equation where the degree is 1 is a linear equation. And if it's a linear equation in one variable, then there's only one variable, x or y, or whichever one we're working with, and that highest power is 1. So if you have a linear equation in one variable, then that means you could simplify things down so that there's just an x term and just a constant term. There wouldn't be anything else. There wouldn't be any x squareds because that would make it not linear. There wouldn't be other variables because that would make it not have only one variable. And so let's get into solving. I'm going to start with multiplying my bracket out on the left-hand side. Well, I have 1/3 x plus 1/3 times 3, which is 1. And I'll expand that bracket on the right as well. 2/5 times 3x, that's 6/5 x. And minus 2/5 times 1, which is minus 2/5. And now I'm just going to bring all the x's to one side and all the constants to the other. So 1/3 x minus 6/5 x. And on the right side I have that negative 2/5. I'll bring the 1 to the other side, bring the 2 to the other side. And then as far as the arithmetic side of things go, again, use your calculator to simplify what is 1/3 minus 6/5. Using my calculator, I can find that that's negative 13/15. And on the right side, I have minus 2/5 minus 1 and plus 2, and that is positive 3/5. And then last thing that I need to do is just to solve for x, and I'll do that by dividing both sides of the equation by negative 13/15. And again, use your calculator. Don't sit around and do this all by hand. Fraction work can take a lot of time, so we don't want to spend our time doing the arithmetic side of things. We want to work on the algebra side of things. 3/5 divided by negative 13/15, that is negative 9/13. And so my solution set has just a single value in it, negative 9/13. We'll do one more. This one's a little bit nicer. This is a little bit easier to do. There's no fractions involved. I'm just going to expand the left side. So 2 times 5x minus 4 times 2. And then the right side, x minus 3. I'll bring the x's to one side. I'll bring the constants to the other. And then on the right side, I've got 3. And on the left side, I've got 9x. And so there we go. I have 9x equals to 3, or x equals to 3 divided by 9, which in simplest terms, that's 1/3. I do expect, by the way, my fractions to be given to me in simplest terms. So 3/9, yes, that's correct, but I do want to see 1/3 as our final answer, because again, we should have things as simplified as possible. So my solution set here, only one solution again, and it's the value 1/3. Now, one thing that we can do is, of course, check our answer. And I didn't do that with the last one, but I'll do that with this one. I'm not going to do this all the time, but it's a good idea to check your solutions. And we check our solutions by substituting in our solution to see, does it make the left side and the right side equal to each other? So if I were to put in 1/3 on the left side of the equation for x, I would have 2 times 5 times 1/3 minus 4 plus 2. Now, the thing with this, just the way that I've written it, again, don't spend your time doing this arithmetic by hand. You can actually do the arithmetic just using your calculator. If I were to enter things exactly as I have them, which is 2 times left bracket 5 times a third, and I'm using my fraction button for the third. I'm not turning this into a decimal because, again, we want to make sure that we get an exact answer. Then minus 4, closing my right bracket, and then plus 2. And if I hit equals, I get negative 2 2/3, or as an improper fraction, I get negative 8/3. And I'll check on the right side. If I were to put in 1/3 in for x, I would have 1/3 minus 3, and 1/3 minus 3 is also negative 8/3. So I can conclude left side for sure is equal to the right side here when x has a value of 1/3. So I am now confident that yes, my answer of 1/3 is correct. I don't have to have any doubt in my mind. I know that this is the correct answer because I've confirmed it by checking my solutions. And that's the nice thing. When you're solving equations, you can always check your solutions. So if you have a few spare minutes, make sure you do that extra step. Okay, next question is the questions about rational equations. So far we've looked at equations in one variable, and the ones that we had before were things that were a polynomial on one side of the equation and a polynomial on the other side of the equation. And that was what we had in the last two examples. Now, you can have equations where one side or both sides of the equation contain rational expressions. So we're going to use the same sort of technique that we did back in the previous chapter when we were simplifying things like complex fractions or simplifying rational expressions. If we were to multiply both sides of the equation by that common denominator that those fractions should have, that would clear out all of those denominators and now give us just polynomials on one side and the other side of the equation. The one thing we'll have to be careful about is this, excluded values. If we recall back when we talked about rational equations, rational expressions for the first time, any value of x that made that rational expression undefined, any value of x that made the denominator 0, was a value that we had to exclude. It was not a value that could be put in for x. So we'll need to be thinking about that as we're solving, because any value that's an excluded value can't be a solution. If it's excluded, it can't be put into one or more of those rational expressions, which means it can't be a solution to our equation. So here I've got a nice little rational equation. X over x minus 4 equals x minus 2 over x minus 1. And it says to state any excluded values. And actually, I'm going to do that first. And the reason I'm going to do that first is so that by the time I get to the end and I've done my solving, I can go back and check and find out, is my solution actually one of those excluded values? Do I need to reject that solution? That's a possibility that can happen. We can find a solution and then it turns out that it's actually excluded and it must be rejected. So let's start with our excluded values. For the left side of the equation, if x were 4, that would make the denominator 0, and that means that the left side of the equation would be undefined. So x can't be 4. And on the right side of the equation, x minus 2 over x minus 1, the denominator would be 0 if x were 1, so 1 needs to be excluded as well. So the one thing that we know before we do any solving, no matter what, x cannot be 4 and x cannot be 1, so neither of those two values could be solutions. If we wound up finding that 1 or 4 was a solution, we would have to reject it. Okay, so now let's get to solving. If we're looking at the two rational expressions that we have, the common denominator for those would be x minus 1 times x minus 4. So that's what I'll do. I'm going to take my equation, and on the left side, as well as on the right side, I'm going to multiply by x minus 1 times x minus 4. And the reason this is a good move is because now my denominators will cancel. On the left side, the x minus 4 and the x minus 4 cancel. And on the right side, the x minus 1 and the x minus 1 cancel, leaving me with just x times x minus 1 on the left side and x minus 2 times x minus 4 on the right side. And now all I need to do is just simplify. Left side, I'll expand that, x squared minus x. And on the right side, I'll expand that, multiplying that out. If you multiply it and then simplify, on the right side, that should simplify to giving you x squared minus 6x plus 8. And I'll bring all the x's to one side and all the constants to the other. So constants, there's just the 8. We'll leave that on the right side. And if I move all of the x terms on the left side, the x squared and the x squared will cancel each other out. And for x's, I'll be just left with 5x. And so that means that x should be 8/5. So for my solution set, just a single value, and it's the value 8/5. Now, I am not worried about that solution because it's not one of my two excluded values. It's always important. We need to look back when we have any sort of a rational equation. Is our solution one of the excluded values? And the answer is no, it's not, which means that we don't have to reject it. We keep it. We say that yes, indeed, that is our solution, and it is 8/5. And I'll leave it for you as an exercise to take a few minutes with your calculator and check that solution. Check to see that if you were to substitute in 8/5 for x, that would make the left side and the right side of the equations equal to each other. Okay, so we'll pause here, and when we come back in the next video, we'll talk about linear equations with two variables, which are equations of straight lines, and we'll talk about slopes and intercepts and all of those wonderful things.